The date October 3, 2025 marks a pivotal moment in astronomical history. NASA's Perseverance rover, stationed on the Martian surface, successfully captured photographic evidence of 3 Atlas, an extraordinary interstellar visitor that has baffled scientists worldwide. While the initial images weren't particularly clear, astrophotographer Simeon Schmaus employed advanced stacking techniques, combining 20 separate rover photographs to reveal a distinctive, luminous smudge position precisely where computational models predicted the mysterious object would appear. The discovery has generated intense discussion and analysis across scientific communities, yet the circumstances surrounding the observation raise profound questions. In an unprecedented move that coincided exactly with this historic observation opportunity, NASA implemented a massive workforce reduction, furloughing approximately 15,000 employees. This timing appears particularly suspicious, given that multiple sophisticated observation platforms were optimally positioned to capture the most detailed imagery ever possible of an interstellar object, the Mars Reconnaissance Orbiter, equipped with high-resolution imaging capabilities exceeding Perseverance's camera system by a factor of 30, maintained perfect positioning for what should have been the photographic opportunity of a lifetime. Similarly, the European Space Agency's Mars Express mission and the ExoMars Trace Gas Orbiter had their advanced instrumentation arrays directed toward the precise location where 3I Atlas was predicted to pass. Despite this unprecedented convergence of observational resources, the high-quality images that should have resulted from these observations remain conspicuously absent from public release. Adding another layer of intrigue to this developing story, remote viewing practitioners had reportedly detected technological components aboard this celestial object months before telescopic observations confirmed the presence of chemical impossibilities in its composition. These psychic investigations, conducted in August 2025, described a thumb drive-sized technological device deliberately embedded within what appeared to be an ancient comet, actively broadcasting electromagnetic impulses across interstellar distances. Approximately 48 hours following the Mars flyby event, social media platforms erupted with extraordinary claims that would fundamentally challenge our understanding of interstellar objects. A Twitter account known as UFO Mania published compelling imagery accompanied by a caption that sent seismic waves throughout the online astronomical community. The post declared that the newest and closest member of the 3 Atlas group, during its passage through our solar system, exhibited characteristics completely inconsistent with natural comet behavior, appearing instead as a perfectly cylindrical structure. The accompanying visual evidence displayed what appeared to be an elongated, geometric object captured during the Mars flyby sequence. Within mere hours, this content had been shared thousands of times across multiple social media platforms, generating intense debate between skeptics and believers. What distinguished this particular incident from typical internet conspiracy content was the precision of the supporting data. Coordinates matched official predictions, timing aligned perfectly with known trajectories, and most significantly, the continued silence from official, governmental and scientific CHANNELS matched the pattern of information suppression. The critical point that remains largely undiscussed in mainstream coverage is the stark absence of official imagery from October 3rd, when 3I Atlas achieved its closest approach to Mars at approximately 29 million kilometers distance. This represented humanity's optimal opportunity to capture unprecedented detailed imagery of an interstellar visitor. The high-resolution imaging science experiment camera aboard NASA's Mars Reconnaissance Orbiter was positioned with perfect geometry for observations. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter missions had their complete instrument suites trained on the exact predicted location. Multiple spacecraft, operating from various angles and utilizing the most advanced resolution capabilities ever deployed for interstellar object observation, should have produced a treasure trove of scientific imagery. Instead, the public received nothing but an official silence that has persisted for weeks following the event. Into this void of official information stepped voices that couldn't be easily dismissed or ignored. An account identifying itself as 3I Atlas Anomaly began posting highly detailed technical analyses that demonstrated far greater sophistication than typical conspiracy theory content. These posts presented 10 specific observational points, each supported by citations to actual scientific instruments, legitimate measurements, and published research papers. The technical breakdown included carbon dioxide-rich coma characteristics revealed through James Webb Space Telescope observations, water and hydroxyl emission signatures detected by the Swift Orbital Observatory, and polarimetric anomalies showing negative to 0.77% polarization measurements at phase angles of 7 degrees, a combination of characteristics unprecedented among catalogued asteroids and comets. Throughout astronomical history, these weren't vague speculative claims but precise citations of real instrumentation, authentic measurements, and verifiable scientific documentation. The level of technical accuracy suggested access to legitimate astronomical data sources, rather than fabricated conspiracy content, contributing to the growing intrigue. A Twitter user identifying as Moneypenny, claiming credentials as a plasma phenomena expert and former BBC journalist, published statements that gave even dedicated skeptics pause for consideration. She claimed that a prominent cosmologist named Stefan Burns believed the object demonstrated intelligent characteristics, surrounded by dusty plasma formations, and exhibited consciousness that was actively communicating both with Earth and other planetary bodies within our solar system. The concept of consciousness engaging in interplanetary communication clearly ventures into speculative territory. Yet the credentials attached to these claims, investigative journalism background, and scientific expertise prevented easy dismissal. Moneypenny added one additional detail that sent chills through anyone closely monitoring the situation. The object could no longer be observed as it had moved too close to the Sun, meaning that December would mark the earliest opportunity for renewed observations, creating a 3-month period of complete observational blindness. The discourse took an even more ominous turn with contributions from John Stewart, a UFO investigator and journalist, who posted content that read like warnings from another era entirely. His communications suggested that his information sources had gone completely silent. NASA was implementing shutdown procedures, and even congressional activities had entered recess periods. Most disturbing were his references to ancient texts warning that the sky will burn with knowing light and the world will forget its reflection. When something called Freeless activated, Stewart's posts included hashtags referencing ancient texts, Vatican files, and Harbinger prophecies, all trending alongside serious technical astronomical discussions. This created an unprecedented situation where legitimate scientific discourse was occurring simultaneously, with references to prophetic warnings and religious texts, making it extremely difficult to separate credible information from speculative interpretation. The uncomfortable reality underlying all these social media developments was the complete absence of official imagery from the Mars flyby event. Despite having NASA's most advanced instruments, the European Space Agency's sophisticated equipment, China's Tianwen-1 mission capabilities, and the UAE's Hope orbiter all positioned for optimal observation, not a single detailed image had been released to the public. The only visual evidence available came from Simeon Schmaus's independent work, stacking 20 images from Perseverance rover's Mastcam-Z camera, revealing nothing more than a faint luminous smudge in the constellation Corona Borealis, near the predicted location. This minimal evidence stood in stark contrast to the capabilities of spacecraft that can resolve surface features smaller than automobiles on the Martian surface. 2 months before the Mars flyby event, before the NASA shutdown, and before any viral social media posts captured public attention, something extraordinary occurred under conditions that make dismissal as wishful thinking or confirmation bias impossible. Bertie Jaworski, former vice president of the Farsight Institute with nearly 30 years of professional remote viewing experience and advanced degrees in digital forensics, was given a set of coordinates by a colleague with absolutely no contextual information provided. This represents standard protocol for legitimate remote viewing operations. The target remains completely blind, with the viewer having zero knowledge of what they're attempting to perceive, until after the session concludes. Jaworski entered her established viewing protocol and began describing perceptions emerging from the coordinate set. Initial impressions described movement through space, something traveling vast distances, something extraordinarily ancient. She characterized it as a natural object, composed of ice and rock, exactly matching expectations for someone attempting to remote view a comet. For an extended period, these impressions remained consistent with natural celestial body characteristics. However, as the session progressed, Jaworski began perceiving something unusual, elements that weren't completely natural. She described discovering what felt like a fingerprint on something that should be pristine, a technological signature where only randomness should exist. Continuing deeper into the viewing session, she perceived something that would fundamentally alter the entire narrative. A small object approximately the size of a thumb drive, something that had been deliberately placed inside the larger structure, not mounted on its surface but embedded within its core. According to Jaworski's detailed report, someone had bored into this ancient rocky, icy object deliberately and placed something encoded with vast amounts of information. She characterized it as resembling an archive, a cosmic message in a bottle, but emphasized that it wasn't merely a passive message, it was active technology of some kind. Her description painted a picture of something unimaginably ancient. Even though the host object itself dated back billions of years, the technological component placed within it was equally ancient. This raised profound questions about whether some species from distant regions of the galaxy had deployed robotic systems to bore into this natural object and embed their technological message. Knowing that this celestial body would continue traveling through the galaxy for eons, the concept isn't entirely foreign. To human experience, the Voyager probes carry golden records designed as time capsules capable of surviving billions of years, hoping that someone, somewhere, might eventually discover them. The idea of using natural objects as vessels for interstellar messages represents a logical extension of concepts we've already implemented. Just considered from the opposite perspective, Jaworski's investigation didn't conclude with the initial session. She conducted 2 additional remote viewing sessions, attempting to understand more completely what she was perceiving. These follow-up sessions revealed information that fundamentally changed the entire picture. The embedded technology was actively broadcasting. She reported that messages were being transmitted in pulse patterns, using present-tense language, not describing historical broadcasts from billions of years ago, but active, ongoing transmissions occurring in real time. When the podcast host conducting the interview mentioned that astronomer Avi Loeb had recently published calculations showing 3I ATLAS originated from the same galactic region as the famous 1977 WOW signal, Jaworski responded without hesitation, stating it was entirely possible that 3I ATLAS was the source of that legendary radio transmission. Jaworski's remote viewing wasn't conducted in isolation. Multiple independent remote viewing groups, working separately without communication between teams, targeted 3I Atlas in the months following its discovery. While specific details varied between different practitioners, certain themes emerged consistently across all investigations: technology, deliberate placement, active broadcasting, and involvement of non-human intelligence. One group reported perceiving humanoid forms associated with the object. Another described what they characterized as graffiti or markings, essentially signatures indicating that someone had deliberately marked or signed the object. Several viewers reported sensations that the object was being masked or camouflaged, deliberately avoiding complete detection as if it didn't want to be fully observed. One particularly detailed remote viewing report mentioned references to special access points, extraction procedures, and time-sensitive elements. These weren't vague mystical impressions but specific technical details that resembled intelligence briefings rather than psychic sessions. more disturbing elements emerged from some viewing sessions, including references to crop circles, advanced spherical craft, hybrid warfare scenarios, and what was described as invisible war. The phrase brain scanning technologies appeared in multiple independent sessions, suggesting that whatever this object represented, it possessed capabilities to influence human consciousness, potentially inciting mass hysteria or hallucination events. While remote viewing remains in the realm of anomalous cognition rather than hard science, the consistency across multiple independent viewers who had no contact with each other was remarkable. More significantly, these subjective impressions aligned in eerie ways with physical anomalies that telescopes were beginning to detect through conventional scientific observation. Consider the implications of Jaworski's August descriptions, a small technological device billions of years old, placed deliberately inside what appeared to be a comet. If such claims were accurate, what would we expect to observe through conventional scientific instruments? From a distance, we would expect the object to display all normal comet characteristics: ice sublimation, dust emission, outgassing patterns, and other typical signatures. However, upon closer examination, we might notice compositional elements that don't quite fit standard models, unusual chemical signatures, unexpected materials, behaviors that seem almost designed rather than random. We would expect the object to possess far greater mass than its visible size suggests, due to something dense remaining at its core, something that doesn't sublime it, or evaporate regardless of how much surface ice boils away under solar heating. Perhaps most significantly, we might expect the object to be transmitting electromagnetic signals, not loudly or obviously, but detectable if you knew where to look, had appropriate instruments pointed in the right direction at optimal times, and could recognize patterns that shouldn't exist in natural phenomena. Jaworski perceived all these characteristics in August, before most scientific data was published, before anomalies became undeniable through telescopic observation, and before NASA implemented its information blackout. She described a cosmic message in a bottle traveling through the galaxy. And now, as 3I, Atlas hides behind the sun-approaching perihelion, as official channels refuse to release Mars flyby imagery, and as amateur astronomers report cylindrical shapes while scientists detect impossible chemistry, that bottle approaches maximum heat and stress. October 29th represents the point where, as Avi Loeb phrased it, confessions are elicited. If there truly is some drive-sized technology buried in the heart of this comet, this date will either reveal its presence or allow it to remain hidden forever. October 3, 2025, was scheduled to be a historic date in astronomical observation, the day humanity would achieve its closest, most detailed examination of an interstellar visitor. The Mars Reconnaissance Orbiter was positioned with perfect geometry, its high-resolution imaging science experiment camera, ready to capture resolution 30 times superior to anything Hubble Space Telescope could achieve. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter stood ready, with complete instrument arrays deployed, at the precise moment when NASA's expertise was most critically needed. 83% of the agency's workforce simply vanished. 15,000 civil servants were furloughed and sent home during what should have been the most intensive observation campaign. In interstellar astronomy history, the official explanation was straightforward. Federal government shutdown due to budget impasse, with no connection to 3I ATLAS observations. Simply unfortunate timing. However, these two words, unfortunate timing, carry tremendous weight when explaining why the world's premier space agency went dark precisely when an object exhibiting 7 statistical impossibilities passed within 29 million kilometers of our Mars-based observation platforms. Consider the astronomical odds of such timing. 3.1 ATLAS was discovered in July 2025. The Mars flyby had been planned and anticipated for months. Scientists understood this would represent their only opportunity to capture high-resolution imagery before the object disappeared behind the sun for months. NASA knew this. The European Space Agency knew this. Every space agency on Earth understood the significance of this observation window. During the final week before closest approach, the United States government implemented a shutdown. NASA's official website ceased updating, press releases stopped entirely, and the army of scientists who should have been analyzing data, processing images, and making groundbreaking discoveries were ordered to leave their posts. Only essential personnel remained, a skeleton crew maintaining critical operations. Yet here's what makes the situation particularly suspicious. Raw image feeds from Perseverance rover continued uploading without interruption. The rover didn't cease operations. The Mars Reconnaissance Orbiter continued functioning normally. The cameras remained active, data collection continued, but public release of information simply stopped. The silence extended beyond NASA to the highest levels of government. During a White House press briefing, Stephen Miller, Deputy Chief of Staff for Policy, was discussing the government shutdown when a reporter posed a question that had been circulating online for days. Has the president been briefed about 3I Atlas? The room fell silent. Miller paused, carefully chose his words, and deflected without providing any substantive response. The briefing continued to other topics, but the question had been asked on camera in an official setting, meaning it could no longer be dismissed as internet conspiracy theorizing. The United States government was being directly questioned about an interstellar object, and they were choosing not to provide answers. Meanwhile, Avi Loeb was making appearances across news networks, Newsmax, CBS, podcasts, and any platform willing to listen. He presented the anomalies with mathematical precision, trajectory alignment with the ecliptic plane, representing 0.2% probability, timing optimized for planetary encounters at 0.005% probability, and 7 characteristics that made 3I ATLAS unlike anything ever catalogued in astronomical history. Loeb consistently returned to one critical point, the necessity of accessing Mars orbiter data. The high-resolution imaging science experiment images could determine the nucleus diameter, resolve structural details, and answer fundamental questions about what we were observing. But those images remained withheld from public release. The European Space Agency released a carefully worded statement confirming that Mars Express and ExoMars Trace Gas Orbiter had successfully observed 3I Atlas during the flyby window from October 1st through 7th. Instruments including the high-resolution stereo camera, color and stereo surface imaging system, and multiple spectrometers had collected comprehensive data. The statement indicated that data would be analyzed over the coming weeks, with results published when ready. However, there were no images, no preliminary findings, no excitement about capturing unprecedented views of an interstellar object at closest range, just dry confirmation that observations had occurred, followed by silence. China's Tianwen-1 mission, silence. The UAE's Hope orbiter, silence. Every spacecraft at Mars had been observing, and every space agency on Earth had chosen not to communicate their findings. This pattern stands in stark contrast to previous interstellar visitor encounters. When Borisov passed through our solar system in 2019, images flooded out immediately. Scientists expressed enthusiasm, press releases proliferated, and the astronomical community celebrated exactly as expected for a rare visitor from beyond our solar system, worthy of intense study and public engagement. Borisov received standard treatment because it behaved exactly like a comet. Correct chemistry, appropriate tail development, expected outgassing patterns. It was interesting because of its interstellar origin, but it wasn't anomalous. It didn't challenge fundamental understanding or raise uncomfortable questions. 3.1 ATLAS does all of those things, which perhaps explains the dramatically different response. There exists a principle in science called Occam's razor. When competing explanations exist, the simplest one is usually correct. One anomaly can be explained away to might represent coincidence. But when 7 statistical impossibilities stack upon each other, Occam's razor begins cutting in a different direction entirely. Anomaly 1, the mass problem when astronomers initially calculated 3I Atlas's size. Based on brightness measurements, they obtained numbers that defied explanation. If all observed light represented reflected sunlight, the object would need to measure between 10 and 20 kilometers across. For context, Oumuamua measured barely 100 meters, while to eye, Borisov was less than 1 kilometer. This object appeared orders of magnitude larger. Statistical models predicting interstellar object detection rates are very clear. Small objects are common, large objects are extraordinarily rare. We should detect hundreds, possibly thousands of Oumuamua-sized visitors before encountering something the size of 3I ATLAS. The probability calculated at roughly 0.01%, one chance in 10,000. However, astrometric data analysis revealed something remarkable. Over the 1,000 measurements from 227 observatories between May and September, when scientists analyzed the object's trajectory compared to pure gravitational acceleration, showed almost no deviation. Despite heavy outgassing losing 150 kilograms of material per second, the object barely deviated from its predicted path. This implies enormous mass, a nucleus so heavy that constant gas and dust jetting cannot push it off course. Calculations suggested more than 33 billion tons, diameter larger than 5 kilometers, making it not just bigger than previous interstellar visitors, but roughly 1 million times more massive than Oumuamua. Anomaly 2, the sun-pointing glow Hubble captured the highest resolution image of 3I Atlas on July 21, 2025. Scientists analyzing this imagery noticed something never documented in any comet. Solar system or interstellar, scattered light extending roughly twice as far toward the sun as perpendicular or opposite to the sun. Comets develop tails pointing away from the sun because radiation pressure pushes dust particles outward. Basic physics confirmed by thousands of observations over centuries. 3.1 ATLAS appeared to violate this fundamental principle. The extension wasn't subtle. A 10-to-1 ratio, 10 times longer in the solar direction than sideways, observed edge-on, meaning true elongation was even more extreme when accounting for viewing geometry. Avi Loeb and Eric Kite published a paper offering explanations involving ice fragments that sublimate at different rates depending on ejection location. The physics was sound, mathematics checked out, but required very specific conditions never before observed in any other comet. A unique configuration that happened to occur in an interstellar visitor already exhibiting multiple other anomalies. Anomaly 3, industrial fingerprint in late August and early September. The Very Large Telescope in Chile trained its UV-ES spectrograph on 3I Atlas and detected something that stopped scientists cold. Nickel atoms in the gas plume, lots of nickel rising exponentially as the object approached. The sun increasing by a power law of roughly 9. The problem? They detected almost no iron. In nature, nickel and iron are born together in supernova explosions occurring in roughly fixed ratios. Every natural comet ever observed shows nickel and iron in similar abundances. To I, Borisov, the previous interstellar comet, displayed normal nickel-to-iron ratios. Every solar system comet shows normal ratios. 3.1 ATLAS was producing nickel without iron. The only place we observe this signature is in industrial production, nickel alloys, materials deliberately refined and separated. The scientists who published this data called it extremely puzzling, noting that temperatures at the object test solar distance were far too low to vaporize refractory minerals containing these metals under normal conditions. Anomaly 4, impossible polarization. When light scatters off particles, it becomes polarized. The degree and direction tell you about particle size, shape, and composition. Comets have characteristic polarization signatures. Hundreds have been measured. Patterns are well understood. 3.1 Atlas showed polarization signatures that don't exist in any catalog. Minus 2.77% at phase angle around 7, inversion angle of only 17. This combination had never been measured in any asteroid or comet, solar system, or interstellar. The closest match wasn't comets at all, but trans-Neptunian objects and a specific centaur called Pholus, icy bodies from outer solar system reaches with very different compositions and histories than typical comets. Anomaly 5, ecliptic alignment. The solar system is essentially flat. Planets orbit in a plane called the ecliptic. Random objects from interstellar space arrive from random directions, crossing that plane at random angles. The probability of an interstellar visitor's orbit aligning within 5 of the ecliptic is roughly 0.2%, 1 in 500. 3.1 ATLAS arrived aligned within 5, moving retrograde opposite to planetary orbit direction. This represents the ideal trajectory for surveying multiple planets with minimum course corrections. Anomaly 6. Planetary timing. 3.1 ATLAS will pass close to 3 planets during its flyby: Venus at 0.65 astronomical units, Mars at 0.19 astronomical units, Jupiter at 0.36 astronomical units. For designing a reconnaissance mission to our solar system, this is the trajectory you would choose. Anomaly 7. Wow signal coincidence in 1977. The Big Ear radio telescope detected a signal so unusual that astronomer Jerry Emmon wrote "wow" in the margins. It came from constellation Sagittarius, lasted 72 seconds, and has never been detected again despite decades of searching. When scientists traced 3.1 ATLAS's trajectory backward through the galaxy, accounting for speed and direction, they calculated where it would have been in 1977, within 9 of the wow signal origin. The probability of this alignment is roughly 0.6%. 7 anomalies, 7 statistical longshots, and we're asked to believe they're all coincidences. October 29th currently, 3.1 ATLAS is hidden behind the Sun, moving toward perihelion, closest approach to our star. For 3.1 ATLAS, that moment arrives October 29th, 2025, at approximately 1 point for astronomical units, just inside Mars's orbit. Perihelion represents a point where physics becomes brutally honest. High-stress environments elicit confessions, as Avi Loeb observed. When you heat ice, it cannot pretend to be anything other than ice. When you heat rock, it behaves like rock. When you heat something pretending to be a comet but might be something else entirely, the mask comes off. Two scenarios exist for what happens at perihelion. Scenario 1. If 3.1 ATLAS is exactly what it appears, an unusually massive, chemically strange, statistically improbable, but natural comet, October 29th marks spectacular activity beginning. Surface temperature rises. Volatiles dormant for billions of years suddenly find themselves bathed in solar radiation. We should see massive outbursts of gas and dust, brightness increasing by factors of 10 or more. Development of proper tails streaming behind as radiation pressure does its work. If the object is fragile, that 5-kilometer diameter mostly loosely bound ice, rather than solid rock, perihelion might tear it apart entirely. We could watch real-time disintegration of an interstellar visitor, providing unprecedented insight into comet internal structure from another star system. Scenario 2, if 3.1 Atlas isn't natural, if anomalies aren't coincidences, if nickel without iron, backwards tail, perfect ecliptic alignment, and wow signal origin means something, perihelion isn't about sublimation, it's about activation. If you were sending a probe to another star system, you'd need it to survive the journey, billions of years in cold radiation impacts. Slow decay of time. Wrapping it in ice makes perfect sense. Ice is common, protective. Makes the probe look natural to any civilization spotting it before it's ready to be noticed. But once that probe reaches the inner solar system, approaches the host star, it needs to wake up. It needs power, and there's only one power source available, the star itself. Perihelion in this scenario isn't a stress test, it's a charging station. The European Space Agency has established a contingency plan. Between November 2nd and 25th, the Jupiter Icy Moons Explorer spacecraft, currently in transit to Jupiter, will redirect its instruments toward 3.1 Atlas. JUICE will observe the object just after perihelion, when it should be at peak activity. When whatever is going to happen has already happened. JUICE wasn't designed to study comets. Its cameras and spectrometers are optimized for icy moons, detecting subsurface oceans, analyzing alien water chemistry. But those same instruments can examine 3.1 ATLAS, and because JUICE is positioned between Earth and Sun, it has viewing angles unavailable from our planet. Data won't be instant. Space communication takes time. Juice is far from home. But by late November, early December, we'll have answers. The same time 3I ATLAS reemerges into Earth's view. December 19th marks the object's closest approach to our planet. Still 1.8 astronomical units away. Still no threat. But close enough that every major observatory will be watching. Close enough to track trajectory with extreme precision. That's when we'll know if anything changed. If orbit matches predictions by gravitational models, we can breathe easier. Another interstellar visitor, strange but natural, passing through on its way back to cosmic darkness. But if numbers are off, if trajectory shows deviations unexplainable by outgassing or solar radiation pressure, then every assumption about our place in the universe needs revision. While scientists debated data and NASA maintained silence, something else was happening, spreading faster than any scientific paper could be peer-reviewed. The internet was catching fire. It started in the United States with TikTok videos showing alleged 3I ATLAS images, some real, mostly fabricated, all accumulating millions of views. Reddit threads sprawled into thousands of comments. Twitter became a battleground between amateur astronomers posting legitimate observations and influencers chasing engagement with increasingly wild claims. In India, the story mutated into something altogether different. WhatsApp, the primary communication tool for hundreds of millions, became a vector for rumors traveling faster than fact-checkers could respond. Forwards in Hindi described alien ships in disguise. Videos narrated with urgent voices claiming the object was changing course. Screenshots of fake news articles with headlines designed to terrify. One particularly viral forward claimed world governments were already negotiating with whoever, or whatever was aboard 3I ATLAS. Another suggested military forces were being mobilized in secret. A third showed edited imagery purporting to be from NASA, stamped classified, showing geometric structure where the comet should be. None of it was true. All of it spread anyway. Brazil saw similar dynamics on Telegram and Facebook. UFO enthusiast communities already primed to see patterns in the sky went into overdrive. Groups that had spent years analyzing lights over the Amazon now had something concrete to analyze. An actual object from interstellar space exhibiting behaviors even scientists called puzzling. The conspiracy ecosystem in Brazil uniquely blends indigenous mythology, Catholic mysticism, and modern UFO lore into something defying easy categorization. 3-1. Atlas became everything to everyone. Harbinger of apocalypse. Vessel of enlightened beings come to save humanity from itself, weapon, gift, test. A screenshot began circulating showing theoretical physicist Michio Kaku. In what appeared to be a television interview, text overlay claimed he'd stated that 3I Atlas was conducting a reconnaissance mission, possibly with hostile intent. The caption read, "It might be an alien probe sent to Earth." The image was real. The context was not. Fact-checkers traced the screenshot to a Nation News interview from February 20th, 2025, months before 3I Atlas was discovered. Kaku had been discussing a completely different topic, likely an asteroid impact scenario. Someone had lifted his image, added false text, and released it into information warfare. It didn't matter that it was fake. The post accumulated over 190,000 views before platforms started flagging it. By then, it had been screenshot and reshared countless times, each iteration becoming harder to trace back to fabrication. NASA attempted response. Their official solar system account posted September 30th, Comet 3I ATLAS poses no threat to Earth. It will remain hundreds of millions of kilometers away from our planet. This is a natural interstellar object, extremely rare and scientifically valuable, but not dangerous. The response was immediate and skeptical. If it's just a comet, why the shutdown? If it's not dangerous, why the silence? If it's natural, explain the nickel without iron. NASA didn't engage further. The statement stood alone, a single tweet against its tsunami of speculation. Early December 2025. 3-1 ATLAS will emerge from behind the sun like a swimmer surfacing after a long dive. Astronomers will find it in constellation Virgo, low on eastern horizon in pre-dawn hours. magnitude 12 or 13. Still too faint for amateur telescopes, but well within reach of professional observatories. Everyone will be watching the numbers. Orbital mechanics is among the most precise sciences we have. Newton's laws, refined by Einstein's relativity, allow us to predict where an object will be years in advance, down to the kilometer. We can account for gravitational perturbations from planets, radiation pressure from sunlight, even subtle push of outgassing as comets shed material. When 3I ATLAS reappears, its position will tell a story. If it's exactly where pure gravitational calculations say it should be, give or take expected deviation from outgassing, we can reasonably conclude nothing unusual happened during its time behind the Sun. It passed perihelion, survived the heat, continued on its predetermined path into the outer solar system, and eventually back to interstellar space. But if the position is off, if trajectory shows changes unexplainable by known forces, then every paper written about this object will need a datum. Every assumption will crack open, because objects don't just change course on their own. Something has to push them. The Vera Rubin Observatory will play a crucial role in what happens next. This telescope, recently operational, represents a revolution in sky surveying. Previous asteroid surveys found around 20,000 new objects annually. Rubin found 2,400 asteroids in its first 10 hours of operation. The implications are staggering. When Rubin focuses on searching for interstellar objects, the trickle becomes a flood. Scientists estimate we could detect dozens of interstellar visitors annually instead of one every few years. Each will be studied with lessons learned from 3I ATLAS fresh in our minds. We'll know what to look for: chemical signatures, polarization characteristics, trajectory alignments. If 3I Atlas is truly anomalous, we'll have other objects for comparison. If it's the first of a new category, Rubin will find its siblings. On October 1, 2025, something passed within 250 miles of Earth at an altitude where astronauts live, and woke aboard the International Space Station. Commercial satellites orbit in carefully tracked paths. But this object, asteroid 2025TF, wasn't tracked at all. We discovered it 6 hours after it had already screamed past us at over 13,000 miles per hour, just above the South Pole. A space rock the size of a small car, moving faster than any bullet, passed through the exact airspace where humanity conducts its most advanced operations. We had no idea it was coming. The Catalina Sky Survey in Arizona detected it at 2:35 a.m. Eastern Time on October 1st using the Bok telescope at Kitt Peak National Observatory. That detection came 6 hours and 36 minutes after the asteroid's closest approach. We didn't see it coming. We saw it leaving. Asteroid 2025TF ranks as the second closest asteroid flyby ever recorded. The record holder, asteroid 2020VT4, passed even closer in November 2020, coming within 370 kilometers of Earth's surface. But that one we also detected after the fact. The issue isn't incompetence. Astronomers and engineers running detection systems are among the world's best. The problem is physics and resources. Small asteroids like 2025TF are incredibly difficult to spot, dark, fast, reflecting minimal sunlight. Our telescope networks are optimized to catch big ones, asteroids larger than 150 meters. That would cause regional devastation. Objects in the 1 to 10 meter range number in millions and remain nearly invisible, until practically on top of us. When asteroid 2025TF was finally spotted, scientists had to work backwards calculating its orbit, determining it follows an elongated path around the Sun, with semi-major axis of 1.62 astronomical units. The orbit brings it as close as 0.676 astronomical units to the Sun at perihelion, and as far as to 0.56 astronomical units at aphelion. Orbital period is roughly to 0.06 years, tilted about 9.1 relative to the ecliptic plane. All numbers come with enormous uncertainty. The orbit is poorly constrained, with condition code 7 meaning calculations are based on just one-day observation arc. A snapshot so brief that predicting where this asteroid will be in the future is more guesswork than science. An object passed closer to Earth than some satellites, and we have only vague ideas of where it came from or where it's going next. It could return, could be on collision course with Earth decades from now, or might never come close again. We simply don't know. For over a year, a rock on Mars has been keeping scientists awake at night, not because it's unusual in size or composition, but because of what is written on its surface patterns. That on Earth would be unmistakable signs of life. On September 10, 2025, NASA made an announcement sending ripples through the scientific community and beyond. Perseverance rover's discovery of potential biosignatures in a sample called Sapphire Canyon had passed the most rigorous scientific scrutiny imaginable, peer review and publication in journal Nature. Acting NASA Administrator Pam Duffy put it bluntly, "This very well could be the clearest sign of life that we've ever found on Mars." On July 24, 2024, Perseverance drilled into an arrowhead-shaped rock nicknamed Cheover Falls in Mars's Jezero crater. The rover's instruments immediately detected something intriguing. The rock surface was covered in leopard spots, small circular features, with lighter centers surrounded by dark rings. These weren't just pretty patterns, they were chemical signatures that on Earth are often created by microbes consuming organic matter and producing specific minerals as waste products. The spots contain vivianite and greigite, to minerals forming in low-temperature, water-rich environments. Vivianite is hydrated iron phosphate often found near decaying organic matter in sediments. Greigite is iron sulfide that some forms of microbial life produce as metabolism byproducts. Finding these minerals together, co-located with organic carbon, creates what geologists call compelling potential biosignature. Cheover Falls sits in geological formation called Bright Angel, located along edges of Neretva Vales, an ancient river valley that once carried water into Jezero crater more than 3 billion years ago. This valley measures roughly quarter-mile wide, suggesting sustained, powerful water flow over long periods. The mudstones and layered sediments in Bright Angel tell the story of dynamic environment, where fast-flowing rivers alternated with periods of calm. Standing water, exactly the kind of environment where, here on Earth, microbial life thrives. The discovery was particularly surprising because Bright Angel represents some of the youngest sedimentary rocks. Perseverance has investigated. Earlier hypotheses assumed signs of ancient life would be confined to older rock formations, remnants of Mars's earliest, most habitable era. Finding these features in relatively younger rocks suggests Mars might have remained habitable longer than previously thought, or that life managed to persist later into the planet's history than imagined. However, this isn't proof of life, it's evidence requiring further investigation. Mission scientist Katie Stack Morgan emphasized, astrobiological claims, particularly those related to potential discovery of past extraterrestrial life, require extraordinary evidence. The peer review process leading to Nature publication was deliberately rigorous, with outside scientists spending an entire year scrutinizing the Mars 2020 team's data and analysis. They looked for alternative explanations, non-biological processes that could create the same patterns. While they found some possibilities, none fit the evidence as well as the biological hypothesis. Perseverance used sophisticated instruments to analyze Cheover Falls, Sherlock scanning habitable environments with Raman and luminescence for organics and chemicals, detected strong spectral signature called the G-band indicating organic carbon. PIXL planetary instrument for X-ray lithochemistry mapped chemical element distribution across the rock's surface with incredible precision. Together, these instruments revealed that organic matter and redox-sensitive minerals weren't just present. They were co-located in the same tiny spots, clustered together in ways strongly suggesting connection. On Earth, this kind of co-location happens constantly in microbial environments. Bacteria consume organic compounds and release minerals as waste. The minerals precipitate right where microbes are living, creating distinctive patterns. The leopard spots on Cheover Falls look remarkably similar to features found in ancient terrestrial rocks where we know microbial activity occurred. To truly confirm whether these features have biological origin, scientists need to bring the Sapphire Canyon sample back to Earth. where it can be analyzed with instruments far more sophisticated than anything we can send to Mars. This is where political drama enters the story. The Mars Sample Return Mission, joint effort between NASA and European Space Agency, was designed to do exactly this: retrieve samples Perseverance has been carefully collecting and deliver them to terrestrial labs. But the mission has been plagued by budget overruns and schedule delays. President Trump's proposed budget for 2026 would cancel the current Mars Sample Return program entirely, zeroing out its funding. Meanwhile, China has announced plans for its own Mars Sample Return mission, potentially launching as early as 2028. If the United States doesn't bring back Perseverance's samples, China might be first to return Martian material to Earth, and they might be the ones to definitively answer whether life ever existed on Mars. On September 9, 2025, Congressman Eric Burleson from Missouri walked into a House Oversight Committee hearing and played a video that nobody in the public had seen before. The footage, dated October 30, 2024, shows a bright spherical object moving against dark background. Then, suddenly, a Hellfire missile enters the frame. The missile strikes the object directly. What happens next defies everything we think we know about how missiles work. The object doesn't explode, doesn't fragment, doesn't even seem to slow down. The missile appears to bounce off and continue on its own trajectory while the orb keeps flying. That's the Hellfire missile smacking into that UFO and just bouncing right off, Burleson said, commenting on the video. And it kept going. He paused, then asked the question echoing through defense circles ever since: I am not going to speculate what it is, but the question is, why are we being blocked from this information consistently? The video was captured by MQ-9 Reaper drone operating off the coast of Yemen. At the time, waters near Yemen were active combat zone with U.S. Navy ships and aircraft protecting commercial shipping lanes from missiles and drones fired by Houthi militants. American forces were regularly shooting down threats in that region. But this object, whatever it was, didn't behave like drone or missile, and certainly didn't respond to Hellfire strike the way any known aircraft would. When asked to authenticate the video and provide details about when and where it was taken, Department of Defense offered no comment. Defense official told reporters, "We do not have anything to provide on this." DOD spokesperson added, "I have nothing for you." The stonewalling only deepened the mystery. The Yemen video wasn't the only revelation at the hearing. Multiple military veterans testified under oath about their own encounters with unidentified anomalous phenomena, the government's current term for what used to be called UFOs. Air Force veteran Dylan Boland described incident from 2012 when he stepped outside for cigarette break during overnight shift at Langley Air Force Base in Virginia. Triangular aircraft hovered above him for several minutes, silent and motionless. Then, according to Boland, the object rapidly ascended to commercial jet level and left the area at high rate of speed. Boland reported the incident through official channels, was interviewed by AARO Pentagon's All-Domain Anomaly Resolution Office in 2023, but instead of being taken seriously, he claims his report was dismissed. Worse, he says he faced workplace retaliation, manipulation of his security clearance, and blacklisting from employment at federal intelligence agencies. His testimony painted a picture of system that doesn't just fail to investigate UAP encounters. It actively punishes those who come forward. Representative Anna Paulina Luna, who chairs the task force, opened the session saying, "For too long, the issue of unidentified anomalous phenomena, commonly known as UAPs, has been shrouded in secrecy, stigma, and in some cases, outright dismissal. This is about national security, government accountability, and the American people's right to the truth. What makes this moment different from decades of UFO speculation? Witnesses on fringe conspiracy theorists, they array military personnel with spotless records, security clearances, and first-hand operational experience. The footage isn't grainy cell phone video from someone's backyard. It is sensor data from advanced military platforms captured during active operations in contested airspace. The resistance to disclosure isn't coming from shadowy cabals. It is coming from official Pentagon officers supposed to be investigating these incidents. ARO has maintained it has no verifiable evidence of extraterrestrial activity or technology, using what it calls rigorous scientific framework and data-driven approach to better understand UAP. But critics point out that many of the most compelling cases, including the Yemen incident, seem to get explained away using logic that doesn't quite add up. In October 2024, scientists made an announcement that should have dominated headlines but somehow got lost in daily life noise. The Sun has reached solar maximum, peak of its 11-year activity cycle. For most people, that sounds like dry astronomy, the kind of thing that matters to researchers but doesn't affect everyday existence. What's happening to our star right now is anything but academic, and the most intense effects might still be ahead of us. The peak of solar activity doesn't mean the end of dramatic events. It means we're entering a phase that could actually produce more geomagnetic storms and more spectacular auroras than the maximum itself. Think of it like firework that burns brightest not at ignition, but during its final explosive moments before fading. The Sun is about to give us its last gasp, and that gasp could light up skies across the planet for the next 2 years. So the physicist P.P. Breck from Norwegian Space Agency put it plainly. It has good news for aurora chasers as peak auroral activity occurs a few years after solar maximum. Thus, we should have several years still with very high aurora activity. We're not at the end of the show, we're approaching the grand finale. During solar maximum, the Sun's surface becomes covered with sunspots, regions of intense magnetic activity, where the star's magnetic field lines become tangled and stressed. When these field lines snap and reconnect, they release enormous amounts of energy in the form of solar flares and coronal mass ejections. Single CME can hurl billions of tons of plasma into space at speeds exceeding million miles per hour. When that plasma slams into Earth's magnetic field, it triggers geomagnetic storms that funnel charged particles toward poles, where they collide with atoms in our atmosphere and create shimmering curtains of light we call auroras. After solar maximum, the number of explosive flares and CME starts to decline. You'd think that would mean fewer auroras, but you'd be wrong. During the declining phase of solar cycle, something else happens. Long-lived coronal holes begin to form, dark regions in Sun's atmosphere, where magnetic field lines open up into space, allowing streams of fast-moving solar wind to escape continuously. These high-speed streams can persist for weeks or even months, battering Earth's magnetic field with sustained pressure that triggers geomagnetic storms, just as dramatic as those caused by CMEs. Solar physicist Sean Doll explained, during the declining phase, we actually have more geomagnetic storms. Maybe the Sun's actual eruption activity slows down a bit after you peak through solar max, but because you still have coronal holes forming and you still have quite a few eruptions. When you add those together, you get more frequent and sometimes more intense auroral displays. We're already seeing this play out. In early October 2025, Earth experienced 5 consecutive days of geomagnetic activity driven by fast solar wind stream from coronal hole. Solar wind speeds reached 768 km per second before gradually declining to 608 km per second. Even at reduced speeds, the wind was strong enough to trigger isolated G1 minor geomagnetic storm levels. Auroras danced across northern latitudes, visible as far south as New York on some nights. Photographers in Iceland, Norway, Canada, and northern United States captured stunning images of green, pink, and purple lights rippling across sky. Scientists are forecasting that current solar cycle 25, could maintain high levels of geomagnetic activity well into 2027 or beyond. Driven by this combination of lingering eruptions and persistent coronal holes, Earth's orientation during equinox season makes our planet more susceptible to geomagnetic storms. During equinoxes, the angle of Earth's magnetic field relative to incoming solar wind creates conditions that allow more particles to penetrate our defenses and trigger strong auroral displays. Practical implications of all this solar activity go beyond pretty lights. Geomagnetic storms can disrupt radio communications, interfere with GPS systems, cause satellite orbits to decay, and in extreme cases, even threaten power grids. during the Great Geomagnetic Storm of March 1989, caused by powerful CME. The entire province of Quebec lost power for 9 hours. Transformers overheated, circuit breakers tripped, and millions of people were left in the dark. Something strange is happening in October 2025. Look up on the right night from the right location and you might see not one, not two, but 3 comets visible simultaneously. All of them are green. All were discovered just this year. One might become bright enough to see with naked eye, rare gift in error, when most comets remain frustratingly dim. The star of this cosmic show is Comet C 2023A3, better known as Comet Tsuchinshan-Atlas, named after Purple Mountain Observatory in China, and Asteroid Terrestrial Impact Last Alert System in South Africa, where it was first spotted on January 9, 2023. For most of the year, Tsuchinshan-ATLAS remained obscure object, tracked by professional astronomers but largely ignored by public. Early predictions suggested it would peak around magnitude for near perihelion in late September, bright enough for binoculars but nowhere near naked eye visibility. Then something unexpected happened. In mid-August, after emerging from solar conjunction when the comet was hidden in sun's glare, observers noticed it was significantly brighter than predicted. By August 19th, its magnitude had jumped to magnitude 8. Short spiky tail became visible and brightening didn't stop. By late September, Comet Tsuchinshan-Atlas had reached magnitude 3, easily visible with naked eye from dark sky sites. Astrophotographers began capturing stunning images showing not just bright nucleus and surrounding coma, but long active iron tail streaming away from sun. Current projections, updated almost daily as new observations come in, suggest the comet reached magnitude -2 on October 12th when it made closest approach to Earth, a distance of 44 million miles, making it brighter than any star except the Sun and easily visible to naked eye even from suburban locations with moderate light pollution. The comet continues brightening after closest approach as it heads away from perihelion. Best viewing is expected through late October, when Tsuchinshan-Atlas passes through constellation Serpens for Northern Hemisphere observers. Comet Tsuchinshan-Atlas follows extremely elongated orbit and may not return for 80,000 years, if it returns at all. But Tsuchinshan-Atlas isn't alone. Comet C 2024 S1 SOHO was discovered just weeks ago by amateur astronomers in images taken by SOHO and Heliospheric Observatory Space-Based Telescope. This comet is a sungrazer, passing extremely close to Sun, and may not survive perihelion passage. The third member of this cosmic trio is Comet 1-P, Pons-Brooks, periodic comet that returns every 71 years. It's currently brightening as it approaches Sun, potentially reaching magnitude 5 or 6 by early 2024. Why are all comets green? The color comes from diatomic carbon molecules to carbon atoms bonded together, which absorb sunlight and re-emit it at wavelength that appears green to human eyes. As comets approach Sun, solar radiation breaks apart larger organic molecules in their icy cores, releasing diatomic carbon into coma. October 13, 2025 marked that date. If all goes according to plan, and with SpaceX that's never guarantee, the world will witness 5th integrated test flight of Starship, the tallest and most powerful rocket ever built. But this isn't just another launch, it represents a crucial moment that could either validate years of explosive development or add another failure to a program that has seen far too many setbacks in 2025. Let's address the elephant in the room. 2025 has not been kind to Starship. The year started with back-to-back explosive failures that shook confidence in the entire program. Integrated Flight Test 3 in March saw the upper stage experience loss of control. During propellant transfer demonstration, multiple Raptor engines shut down, causing loss of attitude control and eventual loss of vehicle during planned re-entry over Indian Ocean. IFT- for in June appeared more successful. The Super Heavy booster completed its planned trajectory and soft landing burn over Gulf of Mexico, while ship completed suborbital flight profile. However, several heat shield tiles were lost during re-entry, and one of ship's flaps was severely damaged, though vehicle managed controlled splashdown. IFT-5 scheduled for October 13th represents the most ambitious test yet attempted. Mission profile includes several groundbreaking objectives that push both technical capabilities and regulatory boundaries. The most audacious goal, attempting to catch Super Heavy booster with Launch Tower S mechanical arms, nicknamed Chopsticks, as it returns from flight. This has never been attempted with any orbital-class rocket. If successful, it would eliminate need for landing legs, reduce vehicle mass, and enable rapid reusability. The booster will perform series of precisely choreographed maneuvers. Engine cut-off at predetermined altitude flip maneuver to orient engines toward ground suicide burn, to arrest downward velocity, and final approach to tower where mechanical arms will attempt to grab it mid-air. If anything goes wrong, if timing is off by seconds, if winds are too strong, if any of 33 Raptor engines fails to restart properly, the booster will be commanded to divert to offshore backup landing zone. The tower and ground equipment are too valuable to risk. Meanwhile, ship upper stage will attempt its own ambitious objectives, demonstrating propellant transfer between internal tanks, testing thermal protection system modifications, and performing controlled re-entry and landing in Indian Ocean. But here is the twist that makes IFT-5 particularly high stakes. It may be the last Starship test flight before significant design changes. Version 2 of both Ship and Super Heavy are already under construction, incorporating lessons learned from previous flights. Version 3 is being designed with even more substantial modifications. If IFT-5 fails spectacularly, critics will point to it as evidence the current Starship design is fundamentally flawed. If booster catch attempt results in damage to launch infrastructure, it could set program back months or years. But if everything works, if booster is successfully caught, if ship completes all test objectives, if heat shield performs as designed, it would represent massive validation of SpaceX's rapid iteration development philosophy and giant leap toward making Starship operational. The stakes couldn't be higher. Starship isn't just rocket, it's centerpiece of SpaceX's vision for future of spaceflight. It's supposed to make access to orbit cheap and routine, enable Mars colonization, revolutionize satellite deployment, refuel itself in orbit, and eventually carry humans beyond Earth on journeys that currently exist only in science fiction. NASA is counting on Starship to land astronauts on Moon during Artemis 3 mission, currently scheduled for 2027. If Starship program continues experiencing setbacks, it could delay American return to lunar surface indefinitely. On May 28, 2025, at 1:31 a.m. local time in China, Long March 3B rocket climbed into night sky above Xichang Satellite Launch Center in Sichuan Province. Most of the world barely noticed. But what the rocket carried into space might answer one of the strangest mysteries. In our cosmic neighborhood, is there a piece of moon floating in orbit around Earth, pretending to be asteroid? The spacecraft is called Chang'e-2, second mission in China's planetary exploration program. Chang'e-1 went to Mars, delivering orbiter and rover that are still operating today. Chang'e-3 will attempt to bring samples back from Mars, potentially beating NASA's troubled Mars sample return program. Chang'e-4 will visit Jupiter and Uranus in single mission. But Chang'e-2 has a target that's much closer and far more mysterious, object called Oumuamua, also known as asteroid 2016 Oumuamua is what astronomers call quasi-satellite, near-Earth object, that appears to orbit our planet even though it is actually orbiting Sun. Its orbit is synchronized with Earth's in such way that from our perspective, it looks like it's dancing around us, never straying too far, never getting pulled away. The asteroid measures between 40 and 100 meters across, roughly size of Ferris wheel. It completes one orbit around Sun every 365 days, almost exactly matching Earth's own year. It's been doing this peculiar dance for at least a century, possibly much longer. But here is what makes Oumuamua truly strange. Its spectrum, the way it reflects sunlight, closely resembles weathered lunar rocks. In 2021, astronomer Ben Sharkey led study suggesting this asteroid might actually be massive boulder, ejected from Moon by ancient impact. The name Oumuamua comes from Hawaiian creation chant that alludes to offspring traveling on its own, poetic description of moon fragment wandering through space while staying near its parent. If this theory is correct, Oumuamua could tell us about Moon's bombardment history, size and energy of impacts that shaped lunar surface, and even provide pristine samples of lunar material that haven't been contaminated by Earth's environment. But there is another possibility. Oumuamua might instead be main belt asteroid that somehow migrated into semi-captured orbit near Earth through gravitational interactions we don't fully understand. That would be equally fascinating, revealing migration pathways through solar system that current models don't predict. The only way to know for sure is to go there and collect samples. That's exactly what Oumuamua is designed to do. Oumuamua is now on year-long journey to Oumuamua. When it arrives in 2026, it will spend another year orbiting tiny asteroid, studying it from close range, mapping its shape and surface, measuring its mass and composition. This will be extraordinarily difficult. Oumuamua is smallest asteroid ever targeted by space mission, and it rotates once every 28 minutes, making it fastest rotator ever visited by spacecraft. Landing on something that small and spinning that fast is like trying to grab merry-go-round while blindfolded. China plans to use 3 different sampling techniques. Hovering approach, where lander matches rotation with asteroid while collecting material. Touch-and-go maneuver similar to what NASA's OSIRIS-REx and Japan's Hayabusa 2 missions used successfully. And most ambitious approach involving using drills on lander's legs to anchor spacecraft to asteroid surface, allowing for more controlled, longer duration sampling. The goal is to collect at least 100 grams of material. That might not sound like much, but when you ray sampling asteroid 40 million miles from Earth with robotic spacecraft operating autonomously because of communication delays, every gram is precious. Once samples are secured, Oumuamua will begin journey home. In 2028, about 2.5 years after launch, it will approach Earth and release re-entry capsule containing asteroid samples. That capsule will have to survive entry speeds of 12.1 kilometers per second, faster than anything returning from Moon, generating temperatures and pressures that will push Chinese heat shield technology to its limits. But here's where mission gets even more ambitious. After releasing sample capsule, Oumuamua won't retire. Instead, it will use Earth for gravitational slingshot, flinging itself onto transfer orbit toward completely different target. Main belt comet 311P Pan-STARRS. The journey will take about 7 years. If everything works, Oumuamua will arrive at comet in mid-2030s, orbit it, and conduct remote sensing studies of this strange hybrid object that has characteristics of both asteroids and comets. Entire mission is designed to last decade, 1 spacecraft to completely different targets. Sample return from quasi-satellite, then rendezvous with main belt comet. It's audacious, complex, and if successful, will demonstrate capabilities that only a handful of nations possess. More importantly, its direct challenge to American space dominance. While NASA struggles with budget cuts, workforce reductions, and political interference, China is executing carefully planned, well-funded program of robotic exploration that's advancing steadily toward ever more ambitious goals. At 12:01 a.m. on October 1, 2025, United States federal government officially shut down. Within hours, 15,000 NASA employees received furlough notices and were sent home. Labs went quiet, offices closed, ongoing research ground to halt. For most of the agency, work stopped entirely, but not for everyone. A small fraction of NASA's workforce, just over 3,000 people, were classified as essential and required to keep working. They won't receive paychecks during shutdown. They'll log their hours and hope for back pay when government reopens. But they have to show up because the work they do literally keeps spacecraft alive. Mission control operations for International Space Station continued uninterrupted. Ground controllers still monitor life support systems, prepare and validate commands, respond to emergencies. About 1,000 commands per day flow from Earth to ISS to maintain operations and keep crew safe. If those controllers were furloughed, astronauts' lives would be at risk, so they work unpaid while Congress argues over budgets. The other major exception to shutdown is Artemis program, NASA's effort to return humans to Moon. Acting Administrator Pam Duffy made agency's priorities crystal clear in social media post before shutdown. China is not going to the moon with good intentions. The implication was obvious: beating China to lunar surface. Is considered national security imperative important enough to exempt thousands of workers and contractors from furlough? But here's what shutdown doesn't tell you. Crisis at NASA began long before October 1st. Earlier in 2025, Office of Management and Budget and acting NASA administrators issued directives to slash agency's workforce by more than 4,000 employees. From end of September through January 9, 2026, thousands of long-time NASA employees are leaving through deferred resignation offers. These aren't furloughs, these are permanent departures. Over 20% of NASA's workforce gone, and it's not just numbers. These resignations have included top-tier talent, engineers who worked on Artemis systems, scientists who manage planetary missions, experts in fields like power systems, propulsion, and life support. One NASA employee at Johnson Space Center in Houston, speaking anonymously, said agency has lost at least one of its foremost experts in power systems. Critical loss for developing nuclear reactor needed to generate power on Moon. The exodus is being driven by budget uncertainty and political pressure. President Trump's proposed budget for fiscal year 2026 requests lowest NASA funding since 1961. Adjusted for inflation, that was year Alan Shepard became first American in space. Budget proposal includes devastating 47% cut to NASA's science programs. If enacted, it would cancel 41 missions, including spacecraft already launched and making discoveries. Let that sink in. 41 missions cancelled. Not missions still being planned or developed, but missions already flying, telescopes already observing distant galaxies, probes already exploring other planets, satellites already monitoring Earth's climate. The proposal would literally turn off spacecraft that had been journeying through solar system for decades, wasting billions of taxpayer dollars and erasing knowledge that can never be recovered. List of threatened missions reads like greatest hits of human space exploration. Nancy Grace Roman Space Telescope, flagship observatory designed to discover hundreds of thousands of exoplanets and survey over billion galaxies, would be cancelled despite being nearly complete. OSIRIS-APEX, currently on its way to study asteroid Apophis during its close flyby of Earth in 2029, would be shut down mid-flight. Mars sample return mission, despite already having samples sitting on Mars waiting to come home, would be abandoned, potentially allowing China to beat America in returning Martian material to Earth. Even missions that have already proven their worth aren't safe. Chandra X-ray Observatory, which has been observing high-energy universe since 1999 and making discoveries that have reshaped astrophysics, is one chopping block. Hubble Space Telescope, perhaps most famous scientific instrument ever built, could see its mission support reduced or eliminated. Proposed cuts don't just affect space exploration. Earth science missions that monitor climate change, track deforestation, measure sea level rise, and provide data essential for weather forecasting and disaster response are also targeted. Planetary defense programs designed to find and track asteroids that could threaten Earth would see reduced funding. Ironic given recent surprise flyby of asteroid 2025TF. Whistleblowers within NASA have spoken out, noting that imposing budget that hasn't been approved by Congress is illegal and defies constitutional principles. NASA's legal office should know better, one said. They should know that what this administration is doing is breaking NASA procedures, NASA regulations, and not following will of Congress. Human cost of these cuts extends beyond NASA employees. Universities across country rely on NASA grants to fund research and pay graduate students. When grant payments halt during shutdowns or budget cuts, entire research programs can collapse. Professors find themselves unable to pay their teams, students lose funding mid-degree. Decades of accumulated expertise and institutional knowledge evaporate, as people are forced to leave field entirely. International partners are watching nervously. NASA's collaboration with European Space Agency on missions like Mars sample return and Artemis program involves binding agreements and shared costs. When NASA unilaterally changes plans or cancels missions, It strains relationships that took decades to build, and undermines America's reputation as a reliable partner. Perhaps most damaging is loss of public trust and scientific momentum. Space exploration is a long game. Missions take years or decades to plan, build, launch, and execute. You can't just pause planetary probe mid-flight and restart it later. You can't delay mission to Jupiter by a year and expect planetary alignment to wait for you. Laws of orbital mechanics don't care about budget cycles or political priorities. When continuity breaks, when programs get cancelled and restarted repeatedly, when talented people leave and aren't replaced, damage compounds. Every cancelled mission is discovery not made. Every lost expert is decades of experience that vanishes. Every shutdown is momentum that has to be painfully rebuilt from scratch. This is October 2025. Asteroids fly past undetected. Potential signs of life sit frozen on Mars. UFOs appear in military footage with no adequate explanation. The sun phases through its final active phase. Comets race toward us from darkness. China executes ambitious missions with clear purpose and stable funding. A private company builds the most powerful rocket in history, while a government agency that once put humans on another world struggles to keep the lights on. The universe doesn't care about our budget debates or political squabbles. It continues its ancient dance, indifferent to whether we choose to watch, to study, to explore, or to simply look away and pretend the cosmos doesn't matter. But it does matter. Every discovery we make, every question we answer, every mystery we unravel adds to the sum total of human understanding and reminds us that we're a part of something vastly larger than ourselves. Right now, we're in danger of forgetting the truth at the exact moment when we need it most. Whether 3I ATLAS represents natural phenomena or something more extraordinary, whether the leopard spots on Mars contain fossils of ancient life, whether the objects in military footage represent breakthrough technology, these questions demand investigation, not institutional paralysis. The coming months will determine not just what these mysteries reveal about the universe, but what our response reveals about ourselves as a species capable of cosmic curiosity and discovery. The choice between exploration and isolation, between knowledge and ignorance, between reaching for the stars and retreating into terrestrial concerns, will define not just this moment, but the trajectory of human civilization itself. The cosmos is calling. The question is whether we'll have the wisdom, courage, and institutional capability to answer.